everyone, this is Dave, and in this video I'm going to show you how to build a Spark application that uses Spark XML and also leverages the DataFrame API in order to consume and manipulate and process XML data. So let's go ahead and dive right on in. So I've created a project in Eclipse called Spark, and this is a Scala project that's been enabled for Maven. So with it Mavenized, it's going to pull in all of our dependencies for us. And so let me just walk through the structure of my project here for just a moment. First thing I'm going to do is show you my POM file. This is pretty much a stock POM file, but what's important here is to show the dependencies that I'm pulling in for this application. And I'm pulling in three. Pulling in Spark Core for Scala 2.10 and pulling in Spark SQL for Scala 2.10, but I'm also pulling in the Spark XML package, and to do that you have to use a group ID of com.databricks. In my case, I'm focused on the Scala 2.10 version, so the artifact ID is Spark-XML underscore 2.10, and the current version I'm using is 0.2.0. And as you can probably tell, I'm using Spark 152 in this application. And those are all of the dependencies that I'm pulling in. Okay, a couple other things about my project here. I do have a data files folder with some XML data in it. One file called books XML, another one that is a UBL order example from Oasis. And this one in particular has namespace information in it, whereas the books XML file does not. So I'll show you a little bit of the differences when the XML content has namespace information versus when it does not. Also, I do have a conf directory or conf folder where I've got my own custom log4j property file. Spark typically logs a lot of information to the console. I wanted to cut that down a little bit, and so created my own prop file and set everything to warn or error or critical where appropriate. That way it's going to cut down a lot of the verbosity of logging that goes to the console, make life a little bit easier. If you go this route, make sure you have the conf directory referenced in your build path. That way when you run, Spark will see this prop file on the class path and pull in the log file settings. Okay. Alright, so let's go ahead and dive right on into the code here. I've got one package called com-demo Spark and one Scala source file here. I'm going to open that up. And first of all, my imports that I'm including here are the Spark config and Spark context. From core, and then from the Spark SQL package, DataFrame and SQL context, and finally the last import is from com.databricks.spark.xml. So this is a package that's outside of core Spark, obviously, but it is available for anyone to use, and you can find it off of the spark.apache.org website. So diving right on into deeper into the code here, you can see that I've got one object, one main entry point, And I'm just doing some simple setup here, setting up a Spark configuration, running it as a local process, creating a Spark context, creating a SQL context. Then I have two functions that I'm going to call, one called load book data. It's going to process my books.xml file, and another one called load UBL data. It's going to process my UBL order XML file. Okay. So let's focus on this first one here, load book data. And what I've got here is I've just declared two variables that are data frames I'm going to use during the demonstration here. And I'm doing an import of the implicits package on the context. And here I'm creating the data frame that's going to hold the data from the book's XML file. So how I'm doing that is I'm calling the read method of the SQL context and passing it a few configuration options. The first one is the format. Format must be XML. And the next one is an option, and the option is for a row tag. And in my case, I'm using book as the row tag. So what is a row tag? Well, with the hierarchy that XML provides, you can see in this example, the root node is catalog, but the actual information that we're interested in is at the level of a book. So we're really just interested in the element information contained within a book. So a book, one record, if you will, is going to be equivalent to a book, and the columns within that row or record is going to be the attributes and the elements and their attributes that are within the book entity. So finally here we do the load and pulling in the file, and I guess just to kick us off here, let's do a print schema and see what that generates for us. So that way you get the benefit of seeing, you know, the schema that's going to be generated for this XML file. So let's go ahead and launch this. And one other thing I wanted to, while this is running in the background, I wanted to show you is there's nothing really special about this XML file. You'll notice there's no schema defined, no DTD. This is pretty much a plain old XML file. You know, it's got a little bit of sophistication with some attributes on different elements and a bit of nesting that's going on here. A little bit of complexity in this specific element here. But aside from that, it's fairly straightforward XML file. Okay, so here's our schema that I got printed out, and because our row tag was at the book level, our schema is going to reflect the information that is contained within a book entity. So here we have author, description, and by the way, the schema is in alphabetical order here, and that's really not going to match up to the ordering that's in the XML file, but that's okay, everything's accounted for. Another thing that's interesting here is the extra element here that has a bit of nesting and child elements. You can see how Spark was able to discern or discover the schema for that and construct the schema in the hierarchy that would represent the data. So that's a really nice value add that we get out of Spark that it does automatically for us, so we don't have to define the schema. Also mention that, and you'll find out that this additional extra element and its children, it's only defined at in one book. So the other books do not have that. And it's a very important point to note, though, because Spark does its best to merge all of the information when it's analyzing the data so that you get a comprehensive schema. In this case, the extra element here and its children could be an optional element. So Spark is going to make the assumption that even though it's defined in this first book entry, it could show up in subsequent ones. So it's going to pull that into the schema. Also, another thing to point out here is Spark was able to discover that price is a floating point value. In this case, it marked it as a double. But also note that we've got date values in here, like publish date. And Spark was not able to discern or discover that that was a date or a timestamp. It marked it as a string. And appears to be the case that, at least for Spark XML, it's going to mark it as a string every time, even with different patterns. You know, if you were to take out the timestamp pattern here and just had a date, it would still mark it in schema as a string. So we're going to have to do a little bit additional work in our coding to deal with things like date comparisons, etc. But I'll show you how to do that, hopefully with very much ease with the functions that Spark provides. Okay, so we've got the schema. So let's go get some information from our data frame that we created. So I'm going to keep the print schema in there, and I like working with XML. So instead of using the DataFrame API to do the selects of the information, I'm going to use the SQL context that I passed in, and I'm just going to issue a select star from books where let's just say I want to find any record or book that has the keyword Microsoft in the description. So let's do an upper on the description column, like, and give the tagging here Microsoft. Okay, so select star from books where upper description like Microsoft. And one thing that we've got to do, though, before we run the SQL statement is we've got to register a temp table called books for our data frame. So you do that by register temp table and give it the table name, and we're going to call ours books. Okay. All right, so we're going to get this going here, and what this is going to return to us is it's going to return any books with the keyword of Microsoft. And just keep in mind we are doing an uppercase conversion of the entries and the values in the description column in order to see if there is a match against the Microsoft keyword in description. All right, so this is running in the background. Should complete here in just a moment. Okay, let's see what it gave us here. Oh, well, we didn't do a show. So while the SQL statement ran, in order to see what it produced, we've got to do a show. So let's go ahead and run this again to see what the SQL statement returns. Okay, so this is running in the background and should complete here momentarily. All right, so it's running, and there's our schema, and there's our result set. So there are indeed 3 records, 3 books in our XML file, and as you can see, the description column does have the keyword Microsoft in it. But let's take a look at these other 2 columns here called extra and gender. They have no values in them. Why would they have no values? Well, let's go back to our books XML file. I think I mentioned earlier that this extra element and its children is only defined in 1 book. So the result set here is pulling back other books that are not this first one. So the Spark SQL engine is going to nicely give you no values back to indicate that there was no data available or no data defined for those columns, for those records, which is exactly what we want it to do. So let's, but what if you want to get at that data? Specifically, let's take a look at this more complex item called extra. Let's go back to the data here, and you can see that there's a lot of nesting going on. We have an extra element, and it has children. You get down to the element called 4, and it has children of 5 and 6, and 6 has children of 7, and 7 is a repeating element. So what if we wanted to get to all the values of 7? How would we do that? Well, we can run a SQL statement, but we have to use the dot notation in order to get that. So we're going to have to query for extra .4, .6, .7. So let's go over back to our code, and let's change our query to reflect that. So it's extra 4, 6, 7, and what I'm going to do is I'm going to change the predicate here. I'm just going to say is not null, so that we'll only get the 1 record with some values in it. So select extra 4, 6, 7 from books where extra 4, 6, 7 is not null. And I'm going to have to take this tick mark out of there. And I think we're ready to go. So let's go run this. I think it was in the process of running before I took the tick mark out. So I'm going to stop it here and restart it. All right, so let's rerun it. And it's running in the background. So This is going to show us what this type of query will return. Now, do want to remind you that 7, the element 7, was a repeating element. So the value that is going to be returned is going to be an array. So, and that's what was just returned. So you can see that we got we have a bracket here, which is indicative of an array, and the first element in that array is 7, 7, 2. If we could see that, it would be 7, 3. So we successfully got the values from the structure. Now, but what if I only wanted, for example, the first value, the very first 7? So in that case, I would have to use the indexing capabilities, where I would bracket it and indicate I want element 0 from that array, and that's all I want back. So in that case, we'll rerun it, and what it's going to return is it's going to return, instead of an array, it's going to return a column that is that only has a string value in it, and it's only going to contain the value of this first 7 element, which coincidentally is the text 7. Okay, so there it was. Alright, so that's how you deal with the nesting nature of XML, and deal with those types of situations where you've got to get down to specific, very specific elements, values for those specific elements. Okay, so let's next talk a little bit about dealing with timestamp values. Now, let's revisit publish date here. It's a string, and as I mentioned earlier, we're going to have to do a little bit more manipulation to be able to do date comparisons on our data. So what I'm going to do is I'm going to comment out the SQL statement, and I'm going to create a new one here. And what we're going to do is we're going to get all of the books from the books table that have a publishing date that is earlier than January 1st, 2001. So how do we do that? Okay, so there's a function called toDate, and you can pass in the column name, and in this case it's called publish date. And we want all of the books that were published prior to January 1st, 2001. So we're going to do less than and another toDate. And we're going to do 2001, 01, 01. Alright, so select star from books where toDate published date less than toDate of January 1st, 2001. So let's go ahead and run that. And you probably already caught on that while this will run, it's not going to show anything. It's not going to show anything because we don't have the show on the end of it. So what we'll do is we'll let this run, and then we'll add in the show. So if you ever have a situation where you're running a SQL statement, because it's very easy to do, you're doing something and you're never getting a result back, it might be that you're not doing a collect or you're not doing a show in order to get the data back. And you see that it actually failed here with an error. So what we're going to do is we're going to do the show. Okay. We're just going to double check one more time. Select star from books where to date, published date, less than to date, January 1st, 2001, and let's do a show. So let's go ahead and run this, and this should run okay for us. All right, so this is running in the background. And there's our schema. Okay, so there's our books that were published prior to January 1st, 2001, and we can see that all of them appear to be that of that case. So let's just for the heck of it, just to prove this thing is really working, we'll change it to where we want all the books that were published after January 1st, 2001. And after this runs, I'm going to show you a way to deal with comparisons all the way down to the timestamp level. Okay, so this is running. And here comes our schema and our result set. Okay, so here you can see that our published date was after January 1st, 2001. All right, so but what if we wanted to be very specific on a timestamp? Let's go back into our books file here, and we can see that this book was published at 2 seconds after midnight on January 1st, 2001. So what if I wanted to find all the books that were published right at 2 seconds after the hour of midnight on January 1st, 2001? How would we do that? Well, obviously you want to have an equal comparison in there, but you can add in a timestamp here into the predicate, so that now I'm going to select all records from books where the published date is equal to the 2 seconds after midnight of January 1st, 2001. And let's go ahead and run that and see what that gives us. All right, so it's running. And we're going to see our excuse me, our schema come up again. And we're going to see our result set, which is just going to be one record, which is the one with the published date of 2 seconds after the hour of midnight on January 1st, 2001. This is exactly what we wanted. Okay, so it's a great way to deal with timestamp comparisons. The Spark API also has a additional helper functions that you can get at different components of timestamps, such as an hour, etc. I won't go into that here, but I would encourage you to look at the Spark API to be able to see how those work, but they're very easy to use. Now, next I want to talk a little bit about what happens if you have a timestamp that really doesn't follow the pattern of year, month, day, and then the timestamp. You know, whether it's maybe a different localized value or just something that's a bit more company specific, or something that's just, you know, very unique to your problem domain. Well, that's at that point what you can do is you can create a conversion routine via a UDF, and I'm going to show you how to do that here. For sake of illustration, we're going to assume that publish date, this publish date, has a different format consistently throughout the XML document. And even though I'm not going to change the XML file, make that assumption. But we're going to, what we're going to do here is we're going to parse out the date using the simple date format object within the java.txt package. And we're going to parse that out to get a Java SQL date. And what we're going to do is the data frame that we have here that we created from within our XML table, we're going to pass that into this convert to date df function. And what we're going to do is we're going to create a new column called pubDate instead of publish date. But its values are going to be based upon the values of publish date, and we're going to use this toDate UDF that I created above to populate it. And we're also going to do a select for just a few specific columns to return. Author, description, genre, ID, price, pub date, which is the new column that we're creating, and title. Okay. So I'm going to go back up to our function that we were in, load book data. I'm going to comment out this last one that we did. And what I'm going to do is I'm going to take our data frame and I want to call convert to date df, and we're going to pass in our data frame that we have, and it's going to return a data frame. So what I'm going to do is I'm just going to do a show on it. That way you can see what it generates after it runs the UDF. So what's going to happen is, since this UDF is being referenced for each record, the publish date it's associated with that record is going to come into this UDF. It's going to get parsed out, and we're going to create a new Java SQL date entry for that, and we're going to return that back from the UDF, and that value is going to be associated with the column name pubDate there, and we're just going to select a few of the columns, including the new column, and just show the results of that. Okay, so looks like it worked. So what we did here, or what we get here rather, is we get the columns that we expect: author, description, genre, ID, price, pub date with the dates there, and title. Okay. And the last thing I'll do here is you can see that everything was returned correctly. But instead of the show, what I'm going to do is I'm going to do a print schema. And what that's going to show you is that whenever we're creating this new data frame, it's going to have its own associated schema. So, and it's going to be a schema reflective of the columns that we've selected. So what you will see is instead of a string value for pub date, you're going to see that the data type that it has associated with it is really a date, which is exactly what we have here. Okay. So there's our schema, has our columns that we selected, and you can see that instead of a string, it has date for pub date. Okay, so that's an example of how you can use the DataFrame API to do some manipulation on your data when you've got to deal with special situations that you've got to parse out values or coerce them in some manner. All right, so let's close our books XML and let's move on to our next example. And the next example that I want to show you is going to be dealing with the load UBL data. If you recall, this file has namespace information in it and throughout. Our row tag is going to be on order. And there's only one order document in this file, so there's only going to be one row. But what's important here is I want to show you some of the nuances that you may have to deal with when there are namespaces in your XML data. All right, so we're done with the book data for the time being, so I'm going to comment that out, and we're going to focus on the UBL data. So let's go down here, and very similar story for the boilerplate. We're reading in with the format of XML. Our row tag is going to be order, because that's what we want our row to be starting with. Basically all information for the order, and we'll load it here. And I'm just going to go ahead and do something very simple here and do a print schema, and make sure I've got that commented out where we don't do the book data. Okay, so let's run this, and what this is going to do is it's going to read our UBL order example XML data and just simply print out the schema for it. But what is really important to pay attention to here is when the schema is shown, you're going to see that it still has the namespace information in the column definition. So so this is running, and let's just let it do its thing here. Okay, so it completed, and you can see here that there's all of the namespace information is still attached to all of the elements in the schema. So this is, you could argue, a good and bad thing. There are multiple namespaces used in here. You can see this one is CAC, and then child elements are CBC. The difficulty with this is that you can't do plain old select statements using the SQL function of the SQL context on this, because it doesn't like the colon. So what you have to do is you have to use the DataFrame API specifically to do selects. And ironically, the column names, even though they'll have the colons in them, they're still going to work. So let me show you an example here. We're going to do a select of a specific column, and I want the CBC ID column. Okay, and I'm just going to go ahead and do a show on that. So even though this has a colon in here, I can still use the API to do the select on the columns that I want in order to get the values. I cannot do something like SQL context.sql and do select star from or select CBC colon ID from UBL data or whatever we name the table, because that would not work. That will blow up. Maybe at some point in the future there will be some way to escape that in a way that's going to allow that to work more properly with plain old SQL statements. But for the time being, you're just going to have to stick with the DataFrame API to do that. Okay, so the query ran, and we've got one record, which is what we'd expect, and a value of 34. And I know for a fact that CBC ID is indeed 34. So it gave us back what we expected, but here again, this is how you have to deal with situations where you have namespace in the column names within the schema. Maybe one day that would change, but at least for the time being, at the current point in time, you have to use the DataFrame API to do the selects. So hopefully this has been helpful, and but this is very powerful stuff, and I wish you well in your endeavors with Spark to process XML data. And please check out my other videos that will soon be forthcoming. Thanks, and feel free to drop me a note if you have any questions, or leave me a comment on the video. Thanks. Bye-bye.